Hey pre-calculus students, we are in section 8.3. We're going to be talking about vectors in three-dimensional space. So before we even get into our notes fully, we need to kind of consider what does three-dimensional space look like when we're talking about the coordinate plane. So basically we started off with, we started off really with x-axis or the x number line, and then we added to it the y number line or the y-axis. And here we go. We recognize that the right side of the x-axis is positive, the left side negative. This part of the y-axis is positive, this part negative. And I'm going to highlight accordingly. So this is the positive part. Let's say the positive is going to be in green there, and this is the positive part of the y-axis, right? And we know the negative part will be down for y-axis and to the left for the x-axis. And the reason why I'm pointing that out is because I want you to think about what's happening here. So the x and y axes literally are flattened, have been flattened and turned onto this red axis here. So what I'd like to show you is that this is the negative part of the y-axis, and this is the positive part of the y-axis. All right. And the positive part of the x-axis is running out towards us, and the negative part of the x-axis is running behind us. So if you took this and you laid it down on a page, in a way you can say that we are kind of talking about it on a sheet of paper, and oriented it like this red coordinate plane is, that would be the XY plane. And then so what we get added to it, and if we were to draw it here, we'd think about this thing coming out and coming back as the z-axis, but that's not how we write it mathematically. I kind of wish we did, but that's not how we do it mathematically. Mathematically, this is the orientation that we'd set up. So z is usually up and x and y laid like this. So as you would think, or as you probably already guessed, the positive portion of the z-axis is up and the negative portion of the z-axis is down. And so this is how we can graph things that are three-dimensional. And we'll be talking a little bit about that during this lesson, most definitely. So you may have thought about the idea of what it would look like to graph a point on the in the coordinate space, in three space. Okay, so if we're talking about that, we would definitely be dealing with, instead of an ordered pair but an ordered triple. So let's say we wanted to graph the point 2, 3, 4. If we wanted to graph this point, we have to recognize that 2 refers to the location on the x-axis, 3 refers to location on the y-axis, and 4 refers to location on the z-axis. So how do we draw such a thing? Well, we're actually going to be using parallelograms to do so. So the first thing we need to do is locate positive 2 on the x-axis, and then we need to locate positive 3 on the y-axis. And instead of drawing a point, we're going to kind of draw a parallelogram here such that the sides are parallel to the axes that we're drawing. So you kind of got to get a sense of this three-dimensional business here. So let me see if I can make this look like what I'm trying to do. So I'm going to start here, and I have the luxury of having the app that's kind of altering my little lines here. So that's the first thing. And so now what I've located here is the point 2, 3, 2, 3, 0, because I haven't yet moved it up or down to talk about its, to represent its z position. So from here, I need to now find 4 on the z-axis. Positive 4 would be here, 1, 2, 3, 4. And so now I'm going to finish off this drawing by actually making somewhat of a cube. All right, so you guys see what I'm doing here. Let's try to make that a little bit better. You guys kind of get what I'm doing. Every time I draw a line, I'm going to make the lines parallel to the axes that I'm drawing over. Hopefully this is looking like something to you guys. Somebody said a hot mess, but I'm trying, chablitos. Okay, so then this point here, let's think about it. We went over 2, up 3, and then up to Z, up here to 4. And so that's the point. This point here is our point 2, 3, 4. That's how we graph it, okay? So now that we can talk about graphing in 3 space, graphing in 3D with these ordered triples, we can also talk about vectors that have that are in space, right? You can talk about vectors that are now shooting out in maybe this direction here or something like that. So now if we can talk about those vectors, we should be able to do the same thing that we did with the vectors when we were dealing with 2 space, right? Flat on the coordinate plane. We were able to use the points to refer to the vector as an ordered pair. Here we'll do an ordered triple. So that's what's happening here. So it says, suppose you have this point is the initial point of a vector and this point is the terminal point, then the ordered triple that represent it, very, very similar to what we did before, is going to be the difference between the x values, the y values, and the z values respectively, and that will be your ordered triple. And then the magnitude really is going to be quite similar. It's going to be the square of each of these values added together, then we'll take the square root. So that's really the principle of what we're going to be talking about in this section. So in this example, we are asked to locate the following point. So we remember this is X, Y, Z, just like an alphabetical order. The first thing we'll do is locate negative X, which we know is going to be going away from us. So I'm going to locate that 1, 2, 3, 4, negative 4, that is, which is there. And then we're going to locate positive 3 on the Y-axis, which is here. So now let me use a gray pen to demonstrate where this is going to go. So it's going to be something like this and like that. So if I was just graphing this in the coordinate plane XY, that's where my point would be at this gray dot. But I'm not doing that. I'm also going to be taking it up to 2. And so I'll put a little mark here. And we know that we're going to continue drawing the rectangles or the parallelograms parallel to the base to create the box that's going to give me my location. Let me go ahead and try that line again. So I'm going to bring this out a little bit further. All right, let's try the whole thing again. All right, then down, then over. Let's make it parallel, something like that. And then we'll do the same thing here. Down, then over, and this is the point. This is that location. Do you guys see the 3-dimensional figure we have to kind of draw in order to find that one point? And that point is the point negative 4, 3, 2. So we've located it on the coordinate in 3 space, I should say. I keep wanting to say the coordinate plane, but that's not right. In example 2, we're supposed to write the ordered triple that represents the vector from X to Y. So we remember that the rule told us in order to represent this as an ordered triple, we're going to find the difference, but we're going to start with the end point and subtract the initial point ordered pair. So we'll start like this. 4 minus 5 is going to give me negative 1. So that's for the X value. And then negative 5 minus a minus 3 will give me a negative 2. And then finally 6 minus 2 will give me a 4. And so that's really it. That's all we needed to do. If we were to find the magnitude, we would square each of these, add them up, and then take the square root. Entomology. Okay, so entomology is the study of insects, and entomologists often use time-lapse photography to study the flying behavior of bees. They have discovered that worker honeybees let other workers know about new sources of food by rapidly vibrating their wings and performing a dance. Researchers have been able to create 3-dimensional models using vectors to represent the flying behavior of bees. So, in reference to this little passage, we are supposing that the flight of a honeybee pass through point 033 and then point 504, in which in which each unit represents a meter. What is the magnitude of the displacement of the bee experience in traveling from these 2 points? All right, so we can kind of look at this as the initial point and this is the terminal point and kind of come up with a ordered triple to represent the situation. So let's call this point A, let's call this point B, and we can classify or write down a different way of looking at this vector AB as the difference between, so 5 minus 0 is 5, and then 0 minus 3 is negative 3, and then 4 minus 3 is 1. So this is the way we could look at the vector. And we remember to find the magnitude of such a vector, we're just going to take the square root of the sum. Let me see if I can do that again. Take the square root of the sum of the squares of each of these component parts. So 5 squared is going to be 25 plus negative 3 squared, which is 9 plus 1. And so 25 plus 9 plus 1 is going to be 35. So the answer is going to be the square root of 35. That's the magnitude, and that's in meters as they mentioned. And so that's going to be somewhere close to 6. It's going to be like 5.8, 5.9. Okay? I think 5.8 actually might be closer. Okay, 5.9. So here we're asked to find an ordered triple that represents 3 times the vector p minus 2 times the vector p. If p, vector p, is given or represented by the ordered triple 3, 0, 4, and vector q is represented by the ordered triple 2, 1, negative 1. All right, so this is going to be a lot like we did last time. So 3 times p would be 3 times kind of like that scalar multiplication we did before. So I'm just going to write it out like that, and then we're going to subtract from that 2 times vector q, which can be written like this. And so when I do that, it really is just a little distributive property. So I end up with 9 minus 0, 12, and then I'm going to subtract from that this vector 4, 2, would that be 2? That's an interesting thought. I think I'm just going to go with the positive. 4, 2, and negative 2. Notice I did not quite distribute through with the negative. I was trying to figure that out for myself, but what I was thinking is I'm just going to leave the negative here and then deal with it later. I hope that made sense. I hope you saw what my little struggle was. And then so now I'm going to do the subtraction, and here's what our final answer is going to be. So 3 times vector p minus 2 times vector q can be written as this ordered triple. 9 minus 4 is 5, 0 minus 2 is negative 2, and finally 12 minus a minus 2 is a positive 14. In example 5, we're to write vector AB as the sum of unit vectors for A beginning at 5, 10, negative 3, and B being at negative 1, 4, and negative 2. Well, first, I think the first thing we should probably do is write this vector as an ordered triple. And so we would be doing B minus A. So we end up with negative 6, negative 6, 4 minus that, and then negative 2 minus that is going to be a positive 1. So this is what we end up with as the ordered triple representation of that. Now what we're going to do is recognize that each of these really is going to give me what my unit vectors are. So remember, my unit vector for the horizontal was I, and then my unit vector for the vertical was J. And so that's going to stay the same. When I'm thinking about the X direction, it's I. When I'm thinking about the Y direction, it's J. But when I'm thinking about the Z direction, it would be K. All right, so now we can write this as negative 6i, last time I forgot my vector signs, plus, or I guess we could say minus, minus 6j, and then plus k, vector k. And so that about sums it up for us. Hopefully this made sense and the 3-dimensional drawing won't be too tricky. All right, guys, look forward to talking to you soon. Bye-bye.